everyone, and welcome to the CIWEM Rivers and Coastal Group Study Weekend Taster Session. My name's Hannah Cooper and I sit on the Rivers and Coastal Group Committee. The event will be recorded. So we're hoping that the event will finish about 7:30, but we might run a little bit short or over time. So we've got 3 technical presentations this evening, and they would have featured at our study weekend that would have happened earlier on this year had COVID not happened. And the weekend was going to focus on the climate emergency and innovation. So our speakers will sort of touch upon this in their presentations. I'm going to speak first and provide a little bit of an overview of what the study weekend is for anyone who isn't aware, and perhaps a little bit what the study weekend next year could look like. Then Karol's going to speak first, and we'll have a short question session after he's spoken. And then Kris and Howard will speak and we'll have questions and then close. So the Rivers and Coastal Group Study Weekend is a weekend-long visit to a host city. It's an opportunity to network and also listen to some talks by some really inspirational speakers about some innovative projects that they're working on. There's normally a couple of site visits as well, and the weekends always focus around a specific theme. It's a completely different opportunity to what you'd be exposed to in your day job, as there's loads of different topics that are covered by the speakers, and it's a really excellent opportunity to meet people as well that you wouldn't normally come across in your day jobs. And obviously the weekend this year couldn't go ahead, which is some of the reason why we're holding this little taster session. So I'm going to talk a little bit about what we did last year throughout these slides. First, I just wanted to cover the geography of the past study weekends that we've held. And we've had pretty good coverage around England. I know we need to venture across into Ireland and Scotland, and I'm really hopeful that after COVID has happened, I guess, that we'll be able to do some more talks in different parts of the country that we haven't been to yet. So the study weekend last year was part of the Rivers and Coastal Group 70th anniversary celebration. And we really saw this as an opportunity to do something really quite ambitious. And we decided to actually hold the weekend in Delft in the Netherlands. And we saw this as a perfect opportunity to tackle quite an interesting theme of planning and innovation within the water sector, as I'm sure many of you will agree that the Dutch have a really innovative approach to flood risk. So these 2 photographs are from the site visits that we attended. The photo on the left is of Mees Landkering, and I'm really sorry if there's any Dutch speakers on the call who would tell me I've pronounced it wrong. But the defence forms part of the Rotterdam storm surge barrier system. And this structure is the largest movable structure on the planet. And when there's no risk of a storm surge, the big gates are open, which allows cargo ships to pass to the Rotterdam port. And it's only when there's a risk of a storm surge that they shut. And on the right was a completely contrasting site visit that we did to the Zandmotor or Sandmotor, which is a much more natural style storm defence. And it behaves similarly to a spit. Several years ago, there was a large amount of sand that was deposited off the coastline in the area, and the sand is being moved via longshore drift rather than erosion acting upon the land behind. And it was absolutely massive. It's created an enormous leisure space and a wildlife habitat. And it's the same technology is actually being used at the moment in the south of England to protect the Bacton gas terminal. So why is it a good idea to engage with the Rivers and Coastal Group study weekends? It's such a great opportunity to network and learn things with people that are like-minded to you. And given that it's a weekend-long event, it's an excellent opportunity to really get a lot of CPD. But it really is quite a different event to a lot of our other events, because you get to spend so long with the people who are also the other delegates. And it's a great opportunity to form some potential career-long friendships that's just really invaluable. These are some quotes from other people who've been involved with organising the study weekend in the past. And I wanted to say that for me personally, if I hadn't engaged with the study weekend, I don't think I would have had the same opportunity to engage with CIWEM in the way that I do now. And it's such a great opportunity that I've been able to get into organising these events and allow for other people to have the opportunity to build these career-long friendships. So is it okay if we do the voting bit now, Jane? I want to just hold a vote to see whether everyone's interested in there being a virtual study weekend next year, or perhaps waiting until 2022, because it's obviously quite unlikely that we're going to be able to hold an event in the same format next year. But I really don't want people to miss out on a potential opportunity if there's interest in us holding a sort of virtual set of events.
We'll just give it about 20 more seconds for people to vote, and then I will share the results.
Thank you. We're really hoping that by 2022, we'll be able to go back to holding them in a similar format to what I've described. It's just really for next year. Thank you, everyone. And yeah, now over to Karol.
Thank you. Hey folks, first of all, thanks for inviting me to give this talk this evening. I hope you find it all interesting. I'm slightly envious of you all because I do appreciate at least 90 odd participants are sitting at home probably having beer or wine whilst watching this, and we're all the rest of us are stuck in the offices. But I'll not hold that against you. So I'm going to talk just quickly about future-proofing flood protections in an urban setting, and this is becoming more and more topical as we move on and as our designs have to take account of the urban setting more so than the rural settings. Just to look at it, I suppose, I'm going to talk roughly about the site locations, and for this I'm going to use two example sites, East Belfast and South Campshire. I want to talk a bit about the constraints that we came across in the scheme, and you'll come across these, all of you, sooner or later when you design these. The design options that I've sort of learned and developed over the years in my career, and the sort of early benefits you can expect going forward. The first important thing to do is that whenever you sit down and look at your brief to design a flood alleviation scheme, it's important that flood alleviation schemes are multi-tools. They can be used more so for public amenity as opposed to just for flood alleviation schemes. There was a time in the past when we were concentrating purely on flood alleviation, but as we look to the future, I think as engineers we all accepted that we have to develop a flood alleviation scheme that does more than just protects against flooding. So I'll cover the site locations. As alluded to, the two sites we're going to talk about, one is in Dublin in South Campshire, and it's actually on one of the main roads in Dublin on the quayside. And the other one's in East Belfast. We are going through heavily urbanised areas. So the need for the scheme, first of all, in Dublin, the South Campshire are a stretch of land approximately a kilometre in length that goes along the south bank of the River Liffey. And Dublin falls north to south. So this is not a major issue for the northern bank, but for the south bank of the River Liffey, once water gets up to a certain point, it flows inwards into the inner city. The rough floodplain you can look at on this, for this basically flood event that we were talking about for our design scheme, was roughly 32 hectares of inner city of Dublin being flooded. Now, bearing in mind that Dublin city is quite an old city and we've got basement houses, major roads and everything. So this was a major event that could occur. East Belfast was what you'd probably typically see in more inner city flooding. The three photographs there are three major roads into Belfast city centre that were inundated. And this doesn't show the devastating effect that it also had the properties and houses in the area. So both schemes were definitely needed to help both from a social, economic and the environmental aspects. Because as you can appreciate, once you have flood water that enters into an urban environment and then has to return, the pollutants and the problems that coincide with that have to be prevented. So now it would be relatively straightforward if it wasn't for the site constraints, and you'll recognize a lot of these constraints as you go through some of your own designs and your careers. The first one was in Dublin. As I said, it was about a kilometre length along the River Liffey. The River Liffey hosts the Dublin tall ships biannually sometimes. That has an economic benefit of around 30 to 50 million euro coming into the city. And that in itself is a massive economical benefit. So whatever you do along this 1 kilometre, you had to take account of, one was that these ships would have to pull alongside and still use this area. And number two, if you can see the photograph on your left, the amount of footfall you get during this festival is basically you have to close roads off and the pedestrians just occupy the entire area. The other thing is that we had a number of historical and abandoned buildings along the area, which told us two things. One, the flood damage in a city centre can cause an area to become very derelict, run down, and people just don't like to use it or move into that area. As I walked along the site, the one thing I did notice is that there was part of the site which was quite well landscaped. You can see on the left-hand side here with trees, we had a cycleway and we had pedestrian movements. But the pedestrians and cyclists always had a conflict there, that people were cutting across. It was nice at the time, but as the demand overtook it, you can imagine how big Dublin city is. And for someone going along from north to south in the city using one cycle lane, it's almost as busy as roads down there. And on the right-hand side, you can see how some of the area was underutilized. We had a large parking bay for some buses that was occasionally used. And we had a horrible grey area that was used for nothing more than just people on occasion walking past, but not used as an open space, for example. So we had to consider all these things. In East Belfast, then we had the typical thing that you probably see as river engineers do inspections, is that horrible grey water, which is really a symptom of being either a channelized river or a river that doesn't get enough air in the water. It's not very good for either the environment or even from people to look at. The river itself also had these typical black fences the whole way along it. It was overgrown. People didn't really even know what was in there. And then on the right-hand side of the slide here, you see the private development and the pressures that come on these local rivers. And bearing in mind, these are small rivers in a big city, and they've got big pressure on them. They have to deal with water, they have to deal with runoff, pollutants, and it's just that development land pushes against it, and you find the point where the top of the bank is really the top of the car park as well. So those are the problems. What I'm going to now show is some of the tips that we sort of come across in innovative design to sort of try and compensate and address those issues. So I suppose we probably all know that traditionally flood management of urban and rural areas just took two general options. The first one was on the urban side, you built your flood wall as close as you could to the top of the bank. And in the rural atmosphere, you flooded as much of the green open space as you possibly could to park the flood water. Moving forward, you generally then get into the solid urban suggestion where the options are basically you build a wall either side of the top of the bank. Then you have to worry about freeboard and probably some climate change. So you just build the wall higher. Now that has two things. One, it changes the velocities of the river itself. the river becomes very channelized, and then the ecosystems within that river suffer dramatically for this. Plus the people then get cut off from the river. And generally once people get cut off from a river, they generally forget about it, or in worst case scenarios, it becomes a very convenient way of dumping materials or just getting stuff thrown over the wall and forgetting about it. So for this option then moving forward for the South Campshire, what we looked at doing was maybe let's pull the flood wall back to as far as we possibly could towards the buildings. Bearing in mind that we're dealing with a different type of flood mechanism here. We're dealing with a coastal flood that would come in over a certain amount of time, so we'd have notice of it. So we could afford to deploy floodgates or the likes of that. So we played around stepping the flood wall back into the city as far as we possibly could, knowing that we had concrete areas there that could act in the same way in a rural environment, using it as a floodplain storage. Then we looked at some of the open space areas. So this one was the first option I showed, was a large concrete area, and you had a handrail in here. As you look behind you in this photograph, the typical Liffey walls are built just on top of the keystones with a bishop-shaped hat stone on the top. So we wanted to somehow replicate that, but we needed to make this area more open. To the right-hand side of this photograph, you have office blocks where there's no green space, no open space, and people weren't congregating in the area. They just went to their office, had lunch at their desk, and then left, and we're trying to make it more open. Plus, this point actually faced one of the most iconic buildings in Dublin, which was Custom House. And generally the tourists just got off the bus, stood on the concrete, took a photograph, got back on the bus and moved away. There was no real atmosphere of the environment. So what we did was we set about and we designed a flood wall that's set in a Z shape. The reason for that is purely that it can rest on top of the historical stone without actually having to bond to the stone itself. So it's protecting the historical atmosphere. We tried to then replicate the same type of wall to the outward eye. It has a reinforced core, but to anyone looking at the wall, it mirrors the existing historical stones on the far side. And we put in some benches and we opened up the entire area. We did a quick traffic survey of the parking bay and actually found it's not overly used. It's almost redundant. So we took it out of the way completely and just opened up the space so it could be used more for the public. With the extra space, we then installed a Dublin bike system, one of the most successful bike systems in all of Europe and heavily used. This then became a commuter hub for people who wanted to use bikes or people who wanted to come across on the bench and sit down and have more of a lunch break outside beside the River Liffey. Moving further down the scheme then, to address the issue of we had to still address the issue of the public pedestrian people interface, how they were going to get through this, how general commuters would make their way across with bicyclists whizzing past. And then we had the inevitable in urban settings, and this was the unchartered surfaces. The one piece of advice I always give people is that any correlation between service records and what actually happens on site is purely coincidental or luck. Don't rely on it at all. Services will always be exactly where you don't want them to be and at a very shallow depth. So we had to take all this into account in our design. We also had to look at where the wall would go. We didn't want to have to start relaying the entire landscape environment around this wall because that would take a longer time. It'd have a massive disruption. Plus we'd also have the people having to use side streets more. So what I struck a line was, I looked at where existing curbs were and lines were already in the environment that we could actually use the wall. So the two blue areas there, or I chose to stagger the wall back and forth. As you get towards the quay, this here's looking upstream now along the Liffey. These are the stones, keystones that the boats would use for the gangways to come onto and they would use to travel up and down. So we wanted to put a flood wall somewhere along here that wouldn't impede that, but also would allow people to come over to have a look at the river. So we wanted to keep it along the existing handrail as possible. So we thought there is a very definite line in the landscape there that we could put our flood wall on without impacting either the keystones or the existing landscape environment behind it. So here's just a quick cross section of what we're looking at. So the top one you can see going from left to right, you've got your handrail here, you've got this massive open area, and then we decided to put the flood wall towards the road. On the road, we looked at rationalizing the road to see could we actually fit a two-way cycle path on the road itself to improve the amenity value. Then in the bottom one, you can see where we've moved the wall inwards again. So people will walk continuously up and down this entire stretch of 1 kilometre without knowing really they're walking through or over a flood defence. Whenever we got to the abandoned buildings, we identified the big problem there was that there was no usable space. These buildings opened out onto a main road. So what we did was we pulled the flood wall as close to the river as possible, giving these properties a door out onto a usable area in the hope that this could regenerate possibly businesses and the likes of that in the economy. So the design itself, to overcome the shallow dig we were permitted, what we devised was a strip foundation of reinforced concrete that would go down along the way. Because we were up against a main road and a river, we wanted to have something that could be deployed relatively quickly without having a massive footprint. So that's why we embarked on using precast concrete units that would be 2 meters in length. The 2 meter units then would sit on top of the concrete strip foundation, and a stainless steel bolt and washer would be used to hold them in position. Then to hide that, they would be cladded with granite on the riverside, and on the city side would have a concrete pattern cast in. Given that all flood defences are always subject to change and moving forward, we designed it to be as adaptable as possible. So the 2 meter sections with the 2 bolts can become an opening in the future, should we ever need it, by actually just cutting the bolts and removing the unit. On the top of the unit, you'll see in the top left-hand corner, a slight notch. The reason for the notch is that in the future, should we ever need to, we basically remove the coping from the top of the wall and another precast unit slips in at the top of it to provide additional freeboard, almost like a Lego set, so that should future generations ever deem necessary to raise the flood wall even further, they have that option. Here we have a view of what it looks like in the finished article. So the left hand here shows you the concrete with a pattern on the left hand, on the inward city side, with a polished concrete coping top. So in theory, future generations could come along, remove that concrete coping, and they'll be presented with a small davit that they can then slot in the additional units in, should it ever require. And then the photograph to the right is looking downstream. So as you can see, you can cast your eye the entire length of the flood defence and walk through the flood defence walls. Now, I do appreciate what everyone's probably saying, holes in a flood defence wall are never good. So what we did was that where the gates didn't require to be opened all the time, only at festivals, we put these industrial or heavy duty black floodgates in that would generally remain in the closed position. But on the footpaths, what we did was that we installed a fold away floodgate. Now these floodgates basically fold into a small shallow compartment held between the 2 flood walls. Once we get notice of a flood warning coming, we start to close these floodgates in a particular sequence. And the sequence is quite simple, is that you open the cover. Beneath the cover is the floodgate itself. You fold it out and then it folds back on itself. The one thing you do have to be careful of is whenever you design any sort of floodgates is to be careful about deployment. Bearing in mind that if you have a major city that has a flood event to address in the future, and as these flood events become more and more prevalent and more unpredictable, we have to have resilience built in. So I didn't want to have floodgates that have to be brought from, say, the other end of the town or through city traffic or through possibly other block roads. That's why I opted for these ones that are already on site and only require to be folded out and can be deployed both easily and by any member of the civil support, fire brigade or the operations unit. It doesn't require much training. It's relatively easy and they can be deployed quickly. On the East Belfast flood alleviation scheme, we had the same sort of problems. And here, the photograph on the left, you can see the sort of this very small, narrow river that was going through these urban areas because basically development pressures had built against it. So what we had to do is we had to enter into land negotiations with both, thankfully, some government departments, but also private landowners to see how could we possibly widen the river as much as possible. Now that took a lot of negotiations where we're having to pull sheet piles closer to people's private property. And therefore we had to sort of try and strike deals or try to get a bargaining tool there to allow this to happen. The reason for that is that what I wanted to end up with is what you can see on the right-hand side, a wider river channel with some sort of greening on the banks to sort of make it more environmentally appealing for other wildlife to come along. On the left-hand side, you can appreciate that we're stuck with a similar problem here. We had development. Now, one trick I would suggest you all consider using is the use of rock armour wherever possible. Rock armour allows you to do 2 things. One, look very carefully at your river to see if possibly the river could take more favour to the left-hand bank on the right-hand bank. What I mean by that is that you could steepen up the left-hand bank to give a wider, greener area on the right-hand bank. Now, all you need to do is look upstream and downstream to see if you can get some sort of green or grass corridor running alongside your river, and that allows wildlife and such not to travel up and downstream. And so you use the rock armour then to steepen one bank, allowing the river to go closer to that bank. This here photograph on the left-hand side demonstrates the sort of the gravel. I would suggest to most of the participants here is not to hurry to remove gravel from the river, as it can provide a very economical way of providing a low flow channel. Also, don't get too upset on what Mother Nature actually intends the river to look like. For example, this gravel shoal I had designed to be upstream about 10 or 20 meters, but then the river goes into flood and the river will correct as to where it should go. Don't try and interfere with a river too much. Let the river find its own natural regime and you'll get better rewards. On the right-hand side here, you can see that basically you can pull a flood wall closer to a private property if, for example, this flood wall then appears more like a red brick finish with a nice coping and fence. It's all about making something that the public in that area will live with and they're happy to live with. They don't want to see a very daunting concrete wall in their back garden. What they prefer to see is their garden wall. That garden wall is a flood defence, but to them it's their garden wall, and we have to appreciate that. So just to look at maybe some of the early benefits to sort of prove that the proof's in the pudding. So this is the old abandoned building, and the door on the left-hand side, you can see opened out onto just a concrete area, had very little appeal. What we seen then was that as soon as we'd finished our flood defence scheme, actually in a matter of possibly a year, this building was then totally renovated into a restaurant and cafeteria on the right-hand side and new startup businesses in the middle. People were already starting to return to this area in both business and for recreational purposes. Here, for example, we have the George's Quay, where now all of a sudden it becomes a focal point for people in the businesses in the area and commuters using it on their bikes. East Belfast, you can probably see better the benefits of widening out the river. If you can widen out the accessibility of the river by either having banks with maybe small timber fences as opposed to these metal railings, and to let vegetation take over, you can see just even by the photograph the water quality difference here, where you can have massive wetlands and greenlands. The area was already in a floodplain, so we weren't really touching it or changing it in any manner. All we were doing is letting the people and the public sort of a better appreciation of the river. So I guess the big things I would take forward in your career going forward with all your design is that the first one is flood levels. The flood levels you always design for today, you check today, you'd always check tomorrow. And by tomorrow, I'm talking about climate change and what the climate could be and the flows could be. But also on all times, always check for the big one, as I call it, or the exceedance, the one above what you've designed for. Once you alter a floodplain in any manner, you have to check to see what happens when your defence is over top, because the flood will behave in a totally different manner, and it's better to be educated and pre-warned for where that will happen. Rivers are living things. We always have to remember that. The closer you get to it, the less you should try to control it. A river generally will look after itself and will adapt to its own regime without interfering with it too much. So I always say you can do a lot of intervention if you're away from the top of the bank, but as you move closer and closer to the top of the bank, the less work you want to do, because the river can take care of itself there if it's given enough room. Your design should always be adaptable, flexible, and keep it as simple as possible. So innovation is always driven by change or constraints, but the most innovative things are always the most simple inventions, the most simplest way forward. So try and adopt a simple, adaptable, and flexible to take account of all the unknowns that you'll inevitably see. The last point I want to point out is the people. The people of any community, any urban area, are the best stewards of a river, but they're only interested in the river if the river, first of all, doesn't flood them, and they can see it and they can see the benefit of it. So if you make the river a feature, people will generally look after it and report it. If you cut them off from the river, then out of sight, out of mind, they just use the river almost as a dumping ground, or they become detached from it and don't really care. And I hope you found that interesting, and I'm sorry if it was a bit of a whistle-stop tour, but I'm happy to take any questions or any comments you may have. And I'll give you back control, Hannah.
Thanks very much for that, Karol. It was really interesting. Yeah, and just to let everybody know, you can just continue to send through questions. I've got a couple that I'm going to ask Karol now, but feel free to keep coming with the questions. So the first question's from Fiona Crayston, and she's asking, are there any issues with vandalism that could impact the fold out of the floodgates?
So generally the fold out floodgates are beneath a galvanized mesh plate, which has a key to open them. And they're no more susceptible to vandalism because they don't allow themselves to be lifted out. I did look at the possibility of using the buildable floodgates, for want of a better word, and these are probably the typical ones we all know, the galvanized sheets of metal that you clip into each other. I wanted to avoid those because generally once you get in there, you can get yourself a few cheap sheets of galvanized and then leg it as quick as you can. So that's why these gates actually, they fold out, so they're all hinged together, and the hinge itself is then set into concrete, and that's how we sort of came across that.
Thank you. So the next question is from Sonia Lee, and says, thank you for the presentation. I was wondering how flood management affects the ecosystem around the river or canal that's being managed.
So generally flood, if you can somehow give the river enough room to manage itself, is always the best one. The ecosystem will always suffer where it's not connected to a natural floodplain. Natural floodplains are fantastic for filtering and they break down pollutants a lot quicker. If you've got a very narrow channel and you cut that area off from the river, it can't offer any benefit at all to the river. And the river then becomes that typical, as I described, as grey water. So any river engineer, once you walk up a river and you see grey water, it's a horrible sinking feeling in your stomach. You know that Mother Nature or the environment around it isn't help filtering. Rivers themselves don't have a filtering ability. They use the banks, the gravels, and the floodplain adjacent to them to filter out all the pollutants that we, unfortunately, as people put into them.
Thank you. I actually also had a question. How do you convince clients that it's worth spending the money on actually not just building the concrete wall schemes?
So if you sit down with your clients and any sort of councils, you'll find there's these what we call pots of money all around the place. Some are developed to, as you said, vandalism. Some is developed to antisocial. Some, it's identifying all those potential pots of money. And generally the pots of money are there because there's an issue or a problem. So you have to sit down, identify all the issues and all the problems in the area. And basically, as a good designer, you have to try and strike a line that gets as many of those pots lined up. And then you sit down with the client and say, by actually diverting that money to do this, you get to solve this problem. And it's a grown-up conversation that you have to have. In order to solve a problem long-term, you may have to do capital investment now, but it will pay off in the long term.
Thank you. I've got a question now from Sally White. How is reducing carbon considered in the design and the construction of the schemes?
Yeah, so carbon is always a problem we have to offset as much as possible. Sometimes you can use GDPR in your concrete, which is always the big thing, concrete additives as much as possible. Plus, if you then have to be as lean with your design as possible. That's why we opted for precast concrete units. So we weren't going to waste a massive amount of steel off cutting and concrete of cutting. It's those sort of things that you can do to best offset it. Plus the future management of the scheme in itself is relatively passive, and that it can sit there with massive carbon input from ever and a day. There's no need for pumping stations or any sort of thing like that there.
Okay, thank you. Okay, I've got a couple more questions now. Patricia Rowley's asked, can you please tell us if the foldable floodgates are standard size or bespoke, and which company design or produce them?
They do come in standard sizes. Generally 2 meters is what you're going to look for. And the reason why you go for 2 meters, or I would recommend going for 2 meters, is that you'll always need to get machinery, or a leaf sweeper or something on the other side of your flood defences. So you don't want them to be very narrow, because then you sort of just cut yourself off for maintenance. So generally 2 meters, they can be bespoke. As for the name of the company, if she drops me an email, I'm sure I'll be able to dig into my emails and find it. It's yeah, I'm afraid it's one of those things with age. I just don't remember the name of the company now, unfortunately.
Okay. Okay, I've got 2 more questions. Rebecca from Rebecca Hoare. To what extent was the stakeholder engagement incorporated in the flood defence designs?
So in the South Campshire, we had a number of meetings with local residents and the Garda Síochána, which is the local Irish police force, the fire brigade and rescue and that. And a majority of their concerns were more about antisocial behaviour in the area. The residents themselves, and what my experience is that residents will generally give some opinion, but at the end of the day, their property is getting flooded. Most, like, could be once a year, could be maybe every 5 years, but it's the fear of flooding they want arrested as quickly as possible. So generally their main concern is that, yes, if you can disguise your flood defences, that they just appear like normal street furniture or normal street landscape, the residents don't object that much. They generally just want digger buckets in the ground to get their house safe, so that, for example, coming up to Christmas, you can imagine setting up your Christmas tree lights in a few months' time, but still being in a flood zone that's not currently protected. And that's a massive mental health issue for people.
Thank you. Okay, I think we've probably got time for like one more question. So this one's from Alice Davey. How much consideration is there on the vegetation that could be used in these schemes?
So the vegetation will be used for one of two things. One is maybe to slow down some of the smaller return periods and sort of allow the river to sort of get a breathing room or to hold back some of the flows. So that vegetation generally will generate itself over the years in the bank. As the engineers, you generally are going there to provide good, reasonable ground conditions for the vegetation to grow. Trees and that can be planted, and generally whenever you have to remove a tree, you always look to plant a native species as close as possible. Choosing where vegetation goes is generally not a major constraint. The one time I would exercise caution is when you're planting large trees close to flood defences, where those trees could endanger the flood defence in the future. And also, if whatever landscaping or planting you consider planting within the river channel, let's say within the flood walls, generally always opt for low maintenance, high ecological return. So basically wildflower meadows, or those sort of grass seedings that have low maintenance but actually allow good habitat for the lives, basically the wildlife that goes along the river channel.
Okay, thank you. I think we've got one last unanswered question, so we'll just do this last one. This is from Claire Ross, and she's asking, is there any programme for maintenance for the gates, i.e. lifting and cleaning them regularly? Yeah,
so generally floodgates are treated, floodgates should be treated the same way as the entire flood defence scheme. So basically you have to check that your flap valves working, your floodgates working and all that there. You have to then set that out clearly for the client. And that's a discussion to have earlier, sooner than later, because that is an ongoing maintenance cost. And when you talk about the rewards coming forward, there is a maintenance cost. Generally these gates, because of their relative short height and easy deployment, they can be basically deployed, checked and repacked away probably within the guts of half an hour per gate. So generally you can do the entire scheme fairly quickly, which is what I would always advise people to do as much as possible. The larger swing gates generally are tested maybe once a year. If that, generally they can sit in the passive position and they're large lumps of steel really. So the less mechanical moving parts, the better in your gates is what I'd recommend.
Thank you very much, Karol. I'm sure, like, I'm just going to offer this on your behalf, but if anybody thinks of any other questions, and you know, you can always email them to Karol. He's put his email address, so I'm sure he doesn't mind. But yeah, thank you. I'm going to hand over to Kris now. I'm going to do that again.
Okay.
Okay.
Is that us, Hannah?
Yes.
Great. Well, welcome everyone, and thanks Anna and the rest of the Rivers and Coastal Group for the opportunity to talk this evening. My name is Kris Calder, and I'm a chartered scientist and chartered water and environmental manager working for RPS in Belfast. The title of my presentation is Mitigating Coastal Erosion in an Environmentally Sensitive Area. So no guesses, no prizes for guess what I'm going to talk about over the next 20 minutes. There we go. Oh, sorry,
Is it working okay?
Sorry, could you move it across to the next slide, Hannah? Thank you.
Sure.
So on the left of this slide is the presentation structure, but probably of more interest. On the right is an aerial picture of Portrane that was taken just after Storm Emma in 2018, when the shoreline retreated by more than 20 meters over a couple of days. And this, as you can see, seriously jeopardized this property here and a number of other adjacent properties. But before continuing with the rest of the presentation, I think it's also worth noting that a recent study commissioned by the EU found that around 20% of the coast around Ireland to be in a state of continuous coastal retreat. So whilst Portrane isn't the only site in Ireland to be threatened by erosion, it's certainly one of the areas that is experiencing the greatest rates of coastal retreat. So just a little bit about Portrane. Portrane is 18 kilometres north of Dublin, and it has a small coastal settlement with a population of just under 2,000 people. Portrane, as you can see here, is a naturally sandy spit that separates the Rogerson estuary here on the left from the Irish Sea on the right. It has wide, extensive flat beaches, and it's very popular with locals for various recreational activities. As you can see from this picture, the site is also of high environmental importance owing to the variety of unique habitat and wildlife found at Portrane. It has just about every designation you can think of, including a special protection area, special area of conservation. It's been designated a Ramsar site, and it's also been proposed as a natural heritage area. So whilst this is great for protecting the environment, it makes our job as coastal managers pretty challenging whenever we're trying to develop coastal management strategies. In terms of the study objectives, we were commissioned by the Office of Public Works in Ireland to undertake a coastal flooding and erosion risk management study in 2018. This is very similar to the FCERM studies in England. And like all of these studies in Ireland, it had a very well-defined workflow as outlined by this graphic. So the main objectives of this study was to reduce the risk of coastal flooding and erosion, and make sure that any scheme that we developed contributed to a healthy natural environment, and of course to make sure any scheme delivered value for money. So skipping back to Portrane, this was a picture taken back in 2012. And you can see on the right here that we have a very wide and flat sandy beach, which was very popular with the locals. We also had this nice boardwalk and around 30 meters of this well-established coastal dune. And behind this dune system, we have a row of around 11 residential properties. Now, just 1 year later, Portrane was making local headlines after a single storm event ravaged almost 15 feet of the coastline, 25 feet of the coastline. At the time, coastal retreat of this magnitude was unprecedented and was attributed to a particularly stormy winter. However, if we skip forward another 6 years, the coastline had retreated an additional 20 meters and it completely undermined one residential property. The local council authority then had to demolish this property under their Dangerous Structures Act and relocate the family. So it was really quite dramatic. You might be asking, has the coastline always been this unstable? And the answer to that is no. Like most beaches, the shoreline in this area tended to erode during winter conditions and then recover during summer conditions. But in general, it remained in around the same position, and we call this dynamically stable. You can see in this figure here that the position of the coastline from 1973 stayed in around the same place right the way up to 1995 or perhaps even 2009. But from 2009, the coastline has actually been retreating landward. So why is erosion such an issue now? Certainly, it's one of the most common questions we're asked. What has changed and why is erosion an issue now? So as with any coastal system, there are several factors that govern erosion. But one of the first things that we looked at was the history of storm events. And to do this, we downloaded data from the Marine Institute's M2 wave buoy, which is located around 100 kilometers offshore. And we looked at the frequency and magnitude of extreme storm events. And what became immediately obvious was that the number, frequency and magnitude of storm events has really increased from around 2013 onwards. What's more is that many of these large storm events coincided with storm surge activity, and this storm surge activity would have increased the local water levels and allowed these big waves to travel right into the coastline and do quite a lot of damage. So that gives you a bit of a historical perspective on the site. The next thing that we had to do was assess the threat of future erosion. And to do this, we used the historical retreat analysis toolbox created by the US Geological Society. The reason that we didn't use morphological models for this exercise is that there are no models that adequately simulate both erosion and dune recovery over the long term. Most models like XBeach and SBeach, or even DHI's Shoreline module, tend to give a very one-sided account of coastal processes, as they're generally set up to look at coastal erosion and not dune recovery. So the historical trend analysis involves identifying the position of the coastline based on historical survey data and quantifying the magnitude of coastal change in between different years. The existing rate of erosion can then be determined by a best fit estimate, and this estimated line can then be projected forward into future years to estimate future coastal change. Using this approach, we found that the coastline at Portrane could actually retreat by up to 70 meters by 2100 if sea levels increased by half a meter under what the OPW call the medium range future climate scenario. And if this was to happen, around 36 properties could be lost to coastal erosion alone. Looking at the high end future scenario whereby sea levels could rise by 1 full meter by 2100, we find that the coastline along Portrane could retreat by almost 90 meters. And this would in turn put around 46 properties at risk of coastal erosion. Moving on to the flood assessment, RPS undertook a coastal flooding assessment using DHI's Mike 21 flood models. And these flood risk assessments accounted for breaches to the dune system and also wave overtopping at relevant locations along the coastline. The overtopping rates were calculated using Eurotop's overtopping tools and were applied to the model as source terms. In the next slide, I've presented flood maps for Portrane for a 1 in 2, 1 in 50, and 1 in 200 year return event scenario. So let's see. This figure on the left illustrates the 1 in 2 year flood extent, and the darker blue in all of these figures represent sea level rise under future climate change scenarios. So under a 1 in 2 year event, you can see that there are a number of properties along the coastline that would be flooded. Under a 1 in 50 year event, you can see that a significant portion of Portrane would be flooded under existing sea level rise conditions. But if we were to add an extra 1 metre onto that to account for the high end future scenario, you can see just how many properties would be affected. And then if we increase that to a 1 in 200 year flood event, you can see that almost all of Portrane would be flooded. In terms of the number of properties that would be affected, we find that under a 1 in 2 year event, around 23 properties would be affected by coastal flooding. Once we increased sea levels to account for future climate change, this number actually increased to 267 properties, which is an increase of more than a factor of 10. We also find that the erosion of the existing dune system that currently affords a good deal of natural flood protection significantly increased the risk of flooding to Portrane under future climate change scenarios. Having quantified the flood and erosion risk of Portrane, we then continued to follow OPW guidelines and moved on to developing options. Coastal management options were considered and developed through an established optioneering process. In brief, this process involved identifying all options regardless of potential obstacles and then removing options that were not considered technically feasible, sustainable, or economically feasible. This table describes just some of the options that were considered for Portrane. Looking at the hard engineered solutions, we have the traditional defences such as your rock armour refitments and breakwaters. The obvious advantages with the hard defences is that they're usually very effective in mitigating the coastal erosion and flood risk. However, on the flip side, they can also impact the natural coastal environment by increasing erosion in adjacent areas and contributing to beach drawdown. On the other hand, we have soft engineering measures that generally work with the environment to enhance the natural protection afforded by the dune system. These tend to be relatively inexpensive options, but they also require quite a lot of maintenance and wouldn't provide the same level of protection as a hard defense would. Then we also have other options such as no active intervention or your do nothing option. We also have managed retreat, which effectively involves creating a sacrificial buffer zone whereby no further development is permitted. The difficulty associated with this option is how do we compensate for people who find themselves in no build zones or sacrificial buffer zones. So having considered these options at a high level, we had to develop a management plan for Portrane. So using Brundtland's Pillars of Sustainability model, we determined that a management plan could only be considered sustainable if it balanced the environmental, economic and social impacts. In respect to the environment, we were talking about, we wanted to develop an option that would work with the natural environment and complied with the Habitats Directive and other relevant legislation. In terms of economics, any scheme should obviously be cost effective and deliver value for money for the local authority. Then we also have social factors. We wanted to develop a scheme that mitigated the risk of coastal flooding and erosion without placing a burden on future generations in terms of very big, substantial maintenance costs going forward. We also didn't want to develop an option that took away from the existing natural environment and say loss of the beach levels, or we didn't want to put something in if you couldn't use the beach as it is. So the first scheme that we developed for Portrane involved constructing over 1 kilometre of rock armour along the shoreline to mitigate erosion. We also had a series of strategically placed embankments to prevent coastal flooding on the rear side of the borough. We estimated that this option would cost around 11 million euros to construct. And depending on detailed design and available budget, we could potentially restore a valued amenity to the beach by creating a boardwalk. The second option that we developed the second option that we developed for Portrane was managed retreat. This was obviously more difficult to define, as at present there is no national strategy or framework in Ireland to implement managed retreat. This is something that needs to be developed by the Irish government and is beyond the control of the local authority. But despite this, RPS based this option on models implemented in other countries throughout Europe, which would involve purchasing and demolishing private property to facilitate future climate change. At Portrane, this could involve purchasing around 13 properties over the short term at a cost of around €3.5 million. Over the longer term, up to another 34 properties would need to be purchased and demolished to facilitate future climate change. Obviously, there are several disadvantages with this option. Firstly, it would do nothing to mitigate the significant coastal flood and erosion risk at Portrane. The second point is that the lack of a national policy means that we can't be certain on how local homeowners would be affected by a policy of managed retreat. And lastly, because Portrane is on a sandy spit, there's only so many times we can keep on going back before we end up in the estuary. So in this instance, there is no natural point to retreat to. The third option that we considered would involve renourishing the beach at Portrane to restore beach levels and constructing special ground structures to control the movement of sand along the beach. Without these structures, any sand placed on the beach would be quickly removed by any storm events. An example of a similar scheme at Clapp-on-Sea is shown in this picture here on your right. Overall, this option would effectively mitigate the risk of erosion and flooding, but it would be significantly more expensive than the other options at a cost of around €16 million with ongoing beach renourishment maintenance. The major constraint associated with this option would be in obtaining planning permission. This could be very difficult as Portrane is surrounded by the environmentally designated areas which are protected by European law. This slide just gives you an artist's impression of what the scheme would look like if it was constructed. And you could see how this scheme would effectively mitigate coastal erosion by restoring the upper beach profile, which would in turn prevent large waves from actually approaching and damaging eroding the coastline. Another benefit is that unlike the rock armour refetment option, this scheme would maintain the natural interaction between the beach and the dune system and would therefore be complementary to the conservation objectives of the nearby environmentally designated areas. So in terms of costs, the next phase of the optioneering process was to determine if any of these options represented value for money through a benefit cost assessment. In brief, a scheme is considered economically viable if it produces a benefit cost ratio of more than 1. So as shown in this graph on your right, there's only a few options that presented good value for money under existing climate conditions. And this was the managed retreat option and the grounds, the nourishment and embankments. Now, obviously, with future climate change, as more properties are put at risk, we get a higher return for any scheme, so the benefit cost ratio actually increases. So in terms of our preferred management plan for Portrane, you can see here that the preferred plan was option 3. The rock armour refetment was rejected, even though it was more cost effective because of the impact that the rock refetment would have on coastal processes. With a refetment in place, beach levels would gradually drop over the next 10 to 20 years to the point whereby beach users couldn't walk along the beach at all phases of the tide. We rejected managed retreat because it did not mitigate the risk of flooding or erosion and therefore didn't meet one of the primary objectives of the study. What's more, the lack of a national strategic policy also meant there is significant uncertainty regarding how homeowners could be compensated in the future. So what's next? So having identified the preferred solution, we're looking at the next stages of the study. And before securing planning permission, we will have to undertake a full environmental impact assessment in accordance with the Habitats Directive. As the scheme is likely to have a significant environmental impact, the local authority are hoping to be granted planning permission under Article 6.4 of the Habitats Directive by demonstrating that there are imperative reasons of overriding public interest that supports the scheme. This is likely to be a significant challenge as there has only ever been one project granted planning through the Habitats Directive IROPI process in Ireland, and that was for the upgrade of an existing wastewater treatment plant in County Sligo, which served over 13,000 residents. So it's going to be a challenging couple of months ahead, but we will pursue nevertheless. But in the meantime, given that the IROPI planning process could take some time, the council were keen to develop some interim solutions to mitigate the risk of erosion over the short term. And to this end, RPS developed a wave attenuation array made from precast concrete units. And the purpose of these units was to effectively trip the waves before they impacted the coastline and therefore slow down erosion. Now, since their installation in 2018, rates of coastal erosion have actually been reduced by around 50% compared to unprotected regions of the beach. Another benefit of the units is that they've created this perched beach area behind the units, and this is very popular with locals who can now use the beach at high tide. Another benefit of this perched beach is that, again, it prevents waves from attacking this area of the coastline. And that brings me on to the final slide to finish. And to finish, I'd like to focus on these pictures on the right. So whilst this is an interesting study from a technical perspective, I think it's important to remember that families have lost their home to coastal erosion here at Portrane, and more families could be affected in the near future. But as hopefully demonstrated in this presentation, developing an effective management plan in an environmentally designated area is far from easy. So there must be a balance going forward. There must be a balance between protecting the environment and protecting local communities that are threatened by erosion and flooding. It might be the Portrane, in the headlines this year, but I'm sure there'll be many other similar cases in Ireland and indeed the UK as the effects of climate change and rising sea levels begin to unfold. And this will no doubt create some very challenging scenarios for us coastal managers and policy makers over the coming decades. In terms of what's needed going forward, well, I think in the case of Ireland, we personally first need a national strategic policy to facilitate managed retreat. Only then can we fully explore all available coastal management options and offer councils and people affected by coastal erosion or flooding a full range of options going forward. That is the end of my presentation, Hannah. I'll hand it back across to you, and I'd be happy to take any questions now or at the end of Howard's presentation.
Yeah, I think, well, first of all, thank you, Kris. That was really interesting. And I think you're right. We do have to not just kind of put these issues on a shelf and say, oh, it's too hard. We need to think about something now before this happens to a lot more communities. But yeah, we're going to have some questions at the end after Howard's presentation, but everybody please do continue to message them onto our Q&A section and we'll get to them at the end. Okay.
Okay, thank you, Hannah. And hello, everybody. Thank you for having me today. My name's Howard Clapp, and I'm a coastal engineer working for Mott MacDonald. I've been working here for 5 years, coming straight out of university. And since working, I've been involved in engineering projects at a series of different stages of the design. So I've done optioneering jobs, detailed design, and I've been based on site. So at the moment, I'm currently doing a supervision role for a concrete revetment project in the Caribbean. And at the moment, and then for this presentation, for the Greater South Flood Alleviation Scheme, I was the designer's site representative. So that meant I was working with the contractor on the job, BAM Nuttall, helping with the design efficiencies and any queries around the design that we had on the job. So hopefully the slides work. Sorry. So yeah, firstly, the presentation, I'm going to start with a quick overview of the project. Then I'm going to run through the United Nations Sustainable Development Goals, just do a quick recap on that. As that was something that we kept in the back of our heads a lot of the time when we were kind of coming up with new sustainable ways that we can improve the quality of the project. I'll then go through some of the detailed wins that we achieved at Greatham South to improve the job in terms of sustainability. And then finally, I'll go through the key lessons that I took away from the project. Greatham South is a flood alleviation scheme in the north of England. On the next slide, I'll sort of show the location. And it mainly focused on development of earth embankments and managed realignment in the area. So at the initial stage of the project, we did a lot of modelling work to work out the best way to set up the managed realignment in the area, and also compensate for some of the habitat loss that that would happen as part of the footprint of the earth embankment. But we also didn't stop there. We carried on when construction was underway, working with BAM Nuttall and with the Environment Agency to identify further ways to make the project more sustainable. So the site is located, as I said, in the north of England, near to Middlesbrough and along an area called Greetham Creek, which is a tributary of the River Tees estuary. For anyone not familiar with the area, it's just sort of south of Newcastle. So Greatham South was the second part of a series of flood defences in the area that were motivated by some flooding that occurs in 2013. And at Greatham South specifically, there was a breach in the existing flood defences, which meant that a large area of the industry was flooded. And that sort of drove the need to improve the defences in that location. So the site itself is quite environmentally sensitive. It's designated as a Ramsar site, and it's also well known for its importance for overwintering birds, bird breeding during spring, and seal populations in the area. And there's often a lot of locals and other people visiting the area who will visit the site, particularly because of the seal populations. So because of this environmental importance, it was always a key part of the project and actually made up a KPI on the job. So next, I'll do a quick run through of the Sustainable Development Goals, just as a quick recap for anyone who's a little bit unfamiliar with them. So they originated, they were put together in 2015 as part of the, sorry, slides have been a bit slow. Yeah, okay, so they were put together in 2015 to form part of the 2030 Agenda for Sustainable Development. And the purpose of the goals is to kind of create a blanket approach to achieving sustainability in a variety of projects in different industries and different sectors. With the end goal being that by 2030, all the countries that signed up to those goals will be incorporating these into all the projects they're involved in. So there are 17 key goals, and then these are broken further into targets and into indicators. So for the Greetham South project, there were sort of several categories that the project ticked. So the first was quality education. We also achieved some industry innovation and infrastructure, sustainable cities and communities, responsible consumption and production, climate action, life below water, life on land, and then perhaps most important of all was the 17th goal, partnerships. And a lot of what was achieved was because there was so much involvement with local stakeholders and a lot of work between the different parties in the project team, so the Environment Agency, BAM Nuttall, and Mott MacDonald, to kind of achieve the other sustainable development goals that we were targeting. And then as I go through the slides, I've kind of put icons of the different sustainable development goals on the slides to kind of show which categories they fit into. So firstly, I'll do a quick on the actual the construction work itself. So as most engineering projects go, they have an element of sustainability in them. Concepts such as a design life mean that you have to consider future conditions and mitigate against them. And when it comes to flood defences, the very purpose of the structure themselves is to kind of manage climate risk. So even if you're not considering future conditions, any kind of improvement works that you do will help climate resilience, because it might reduce the risk that flood defence breaches in a future event. And therefore, the residents and communities in the area are better protected from any storms or any flood events that occur in the area. So for Greetham, the project was, as I said before, a series of earth embankments set back from the original defence line, with the existing defence being breached at the end of the works. The standard protection that we aimed for was a 0.5% annual exceedance probability, or a 1 in 200 flood event, with the design life being 50 years. And because of that, it meant that we had to account for 50 years of sea level rise. So that meant that at the end of the 50 years, that was when the project was achieving the 1 in 200 level of defence. And before that, it was always achieving at least a 1 in 200 or more standard of protection. So one of the first kind of ways that there was some sustainable saving on the project was that by considering managed realignment, we were able to actually minimise the crest levels of the setback defences. The salt marsh that is developing at the moment in front of these defences provide resistance to wave action, and in turn that means that the freeboard that was required for the defences is lower, and therefore less material was needed, instantly making a saving on the carbon and the material use on the project. So then the kind of key area in which there were sustainable kind of achievements on the project is the idea of habitat creation. And it was always a kind of key part of the project from day one. As I said, it was a managed realignment job. So we always knew that we were going to be creating a large area of salt marsh habitat. However, at the start of the project, when we were in the construction phase, we were able to make some efficiencies in the design and in the construction, which meant that we had additional funds to play with, and these were reinvested back into the project. So firstly, there was a culvert that needed repair as part of the project anyway. And this culvert was thought to be feeding saltwater at high tide into a brackish pond on the landward side of the defences. However, on further investigation, the project team found that this actual pond was being fed mainly by freshwater ditches behind the defences, and that the culvert wasn't functioning correctly. So what we did there is that we improved the culvert, and we did some modelling to achieve a new culvert that actually allowed some saltwater to come into the system during a high tide. And that meant that the ponds became more brackish and achieved the habitat that they were originally designed to generate. Unfortunately, of course, converting the freshwater pond to a brackish pond meant that we lost some freshwater habitat. But working with the RSPB, who had quite a heavy presence in the area, we were able to identify another site that was basically just an area of kind of grassland and sort of old farmland and wasn't being used for anything on some industrial land. and this was then converted into a series of ephemeral ponds. So these are ponds that are rainwater and groundwater fed that may dry out during summer months. So what this meant is that we had freshwater ponds during the winter, and even if they did dry out during the summer, the ponds themselves, the vegetation is different, and therefore the habitats in that area are different compared to the surrounding grassland. So it kind of further increased the variety of the ecosystems in that area. And then finally, we identified another low-lying point to the north of the site that was currently being used as farmland and leased from the Environment Agency. This farmland, because of its low-lying nature, was particularly waterlogged, and the farmers' yields were not high. So when we approached him to discuss reducing or to taking the lease back into the Environment Agency and then converting this area into salt marsh habitat, he was fine with that. And we were able to simply create a main channel that connected to the main channel and allowed another area of salt marsh to start developing. And because the area was low-lying with high ground all around it, we didn't even need to create any additional flood defences other than protecting a small area that was adjacent to an old historical landfill in the site, just to protect against any erosion that might occur there. And then in total, we had 48 hectares of habitat created. So the next item is about optimizing cost and carbon. So that's to do with the responsible consumption and production SDG. The project required a huge amount of fill, and that was something we knew from the get-go. So we were able to look around to see if there were any ways that we could reduce the cost of that for us as a project team, and also look at ways to reduce the carbon footprint by trying to find any waste sites that might be put to use to supply the material. Unfortunately, there was a site really near to this construction that we were working on that had a large amount of clay being produced as waste on their projects. So this was a lagoon development on a landfill site, with the lagoon's purpose being a filter for pollutants of any landfill runoff. So it's quite a large, deep lagoon that was designed to kind of let the pollutants settle out. And then when the water eventually worked through a series of lagoons and was released back into the freshwater system, it wouldn't have any pollutants left. This large amount of clay was transported to our site over the course of the project and meant that we were able to reuse waste material at a cheaper rate compared to other quarries for clay in the area. It also meant that we reduced our transport emissions, as the distance was about 5 minutes of driving versus the nearest site being about 20 minutes. So we had about 4 times reduction in our transport emissions there. And given the amount of clay being moved, that's a lot of journeys over the course of the project. And then finally, we had the added benefit that the transport was mainly along roads between the landfill site directly to our site. So we didn't have to use the main public roads, which meant there was less impact on public traffic. The other item that had a big carbon saving on the project was the removal of a concrete pile platform that was thought to be initially required at the design stage. When we got to site, the poor ground that was thought to need this pile platform appeared to be slightly better quality than we initially thought. So we were able to carry out some additional GI to determine whether or not we could reduce the amount of engineering going into the solution. What we found is that instead of using a concrete pile platform, we were able to use a particular aggregate to fill in the water and then increase the height of the embankment above this area of land that we thought might settle more. And that meant that if there was any settlement, we'd still achieve the standard of protection that we needed. So this GI was carried out using a floating pontoon. And then even though we had the increased clay use and this different aggregate used, it was still a much reduced amount of carbon footprint compared to if we'd have been constructing a full concrete pile platform. The kind of final part that I was discussing today is the community engagement that we had on the project. So as I said before, there was a lot of cooperation with the RSPB in the area. So the RSPB, because the reserve was so near to the site and because it's important for wildlife, often had a lot of visitors that would visit the RSPB reserve also come to Greetham South. But because of the construction work, the site wasn't accessible. So in order to maintain this connection with nature that the locals appreciated, we installed a remote camera that was able to be controlled at the RSPB reserve and allowed any school trips and any users of the RSPB reserve to be able to observe the site and watch the seals even when access wasn't available. We were also, towards the end of the works, had to design 2 additional, so one bird hide and one seal hide at the site. And this was to replace an existing seal hide that had been on the site before the start of the works. So we involved a local university, which kind of helped them in terms of learning about material use and actually getting involved in a real life construction projects, and came up with 2 unique designs for seal hides in the area, which kind of promotes the area and further promotes people visiting the site to use it and to connect with nature. And then finally, by having a construction presence in the area, we were able to have a couple of schools visit the site, and we also carried out a couple of ICE Bridges to School events, which meant that we were able to kind of promote STEM to the young generations. So the key lessons of the project, I think the first is clearly that we had a lot of proactive engagement throughout. Even though we had a large amount of habitat created from the get-go in terms of the salt marsh that we were creating by managed realignment, we continued to look at ways to involve local stakeholders and come up with better and better ideas to improve the overall achievement of the project. Secondly, any funds that we did kind of manage to recuperate from the project, we reinvested in these odd projects around this area to make sure that we were maximising the habitat we were creating and the sort of image of that the project was getting in the local area, and further trying to connect to the people who used the site previously. And then I think finally, one that is kind of skimmed over is recognition at the end that we achieved through some of the awards that we went for at the end of the job. And what that kind of meant, I mean, half the reason I think that I'm here and able to present about it is because I was able to, people that I work with knew about the project because of these awards, and it kind of got some recognition. And I think that's quite an important part of any project, that there's a lot of key things and key lessons that are learned and good ideas that come out of engineering projects that are often kind of tucked away when the project comes to an end. So by kind of getting the project out there on the big screen, the inspiration, it becomes an inspiration for other projects. And I think that's something that is key. So if it helps share that knowledge throughout the whole industry. So yeah, that's a quick little run through of Greetham South and how it's achieved some of its sustainable goals. Thanks for listening, guys. And as Hannah said, any questions I'll be happy to answer.
Yes, thanks very much for that, Howard. It was really, really interesting. I'm going to do a bit of a double act question time with Kris as well. So I'll just get the questions up. So yeah, it might just be easier if whoever thinks the question is relevant to them answers it.
I guess the first one's for me.
Yeah.
Terry.
Yeah. Oh yeah, you can see the questions, can't you? Yeah.
I can.
So yeah, from Terry Fuller, was any of the increase in significant wave height due to foreshore lowering / coastal squeeze?
Yes, it partly was. We were able to rerun some of our wave models with updated bathymetry, and we found that there was a significant increase in the nearshore wave heights. And of course, it's just a big feedback loop, because the bigger waves we get in, the more sediment comes off the beach, which in turn allows bigger waves to come in and do more damage. But yes, it's just a big feedback loop, in short.
Thank you. So the next question is from Fiona Crayston. What are your thoughts on community cohesion in managed retreat? For example, if you demolished 13 properties, what effect would that have on the wider community?
Yeah, so I think in general, the consensus was that the majority of the local community preferred the hard engineered option. One of the downsides of managed retreat in this instance was that we had no natural point to retreat back to. And if we continue to let coastal erosion to eat away at the coastline uninterrupted, we're going to start to impact local property prices as well. And that's something that's going to affect somebody who's living not just right on the coastline, but somebody who's maybe 50 or 200 meters back. And what's more, without a clear national policy describing what managed retreat would actually look like, we don't really know how it would be implemented. So again, it's that lack of certainty that the local community didn't like, was just another one of the reasons why they preferred the hard engineered solution.
Yeah. Did you get agreement from the landowners for managed realignment?
No, sorry, the security's trying to throw me out. Give me 2 seconds. 5-10 minutes. I have keys. I'll lock up. Okay. Sorry, knew that would happen. Sorry, Hannah, what was your question again?
So how did you get agreement from the landowners for managed realignment?
Well, we haven't at the moment. The fact is that we are opting for policy option number 3, which provisions the coastal defence solutions. So hopefully it doesn't come to the managed realignment scenario.
On the case of the Greetham job as well. So the land originally belonged to a company that has industry in that area. And they were affected by the floods that occurred in 2013. So their kind of contribution to the funding of the job was to provide that managed realignment area. So there was a second company as well that was involved, and they partly funded the works. But for where the managed realignment area, that company kind of provided their land as their contribution.
Hannah, I've just had a quick scan through all of the questions. I don't think any of the other ones there are for me. Security is quite keen for me to get out of the building so they can lock up. So if you don't mind, I am going to leave you guys to it and sign off. But if there's any other questions, feel free to drop me an email.
Okay, thank you. Yeah, hope you get out okay.
Yeah, thanks. Cheerio. Bye.
Okay, so Howard, there's a question from Tamara Provencher. What sea level rise scenario did you use to respect the 0.5% AEP after the 50 years?
So I was involved mainly on site for the project, so I can't quite remember. It's quite a while ago as well. But I think it was from the UK CPO9 projections. I think it was a medium emissions scenario. So we used that scenario to then come up with a sea level rise. I think that's what they used in the modelling at that stage.
Okay, thank you. Next question from Sophie McCarby. Was there a specific reason for only looking at a 50-year design life?
So I think, again, in that reason, because the area is quite low lying, there was always thoughts that there could be kind of further managed realignment past the 50-year point. And I think the Environment Agency had that in the back of their mind whilst the design was occurring. There was also, I think as part of the works, because it's an earth embankment, it's easier to raise it by just kind of increasing the footprint slightly and building up the backslope, and therefore you can raise the whole embankment to a higher level without having to do it all at the front end of the works. So I think that's the other kind of reason that we looked at 50 years, is it meant there was a bit more adaptability in the final design solution. So rather than looking at the 100 years as a whole thing, the solutions for the first 50 And then past that point, they can either be further works on the embankments if it's deemed necessary, and the kind of climate predictions are showing that there's going to be continued sea level rise. Or if there's any changes to those predictions, then perhaps the existing embankments might remain suitable.
Thank you. Next question is, have there been any ecological studies on the ponds after the works were done?
I know that there are planned studies. So the Environment Agency in the area we're doing surveys already on a mandatory alignment that occurred at the north area of the site before the Greetham South project started. And I think going forwards, the surveys that uncovered that area will now cover the wider works. There'll be surveys over the Greetham South main salt marsh mandatory alignment area, and also the ponds, the brackish waters, and the second mandatory alignment site that we identified under the works. So yeah, that will kind of all get grouped together.
Thank you. Two more questions. For Greetham South, was there a concern that the extra tidal volume introduced by the realignment would cause erosion or widening of the creek?
Yes, so yeah, I'm aware that when you increase your tidal prism, that you can end up with the rate of flow coming into the creek to be increased. So there were a few areas around the site that we'd already identified as being at risk from erosion under the original scheme. So what was done there is where we had to put in some scour protection, that was slightly over-engineered. So where the flow rates were quite low anyway, so where we were coming back with flows that suggested vegetation would probably be fine for resisting most flows, we actually put in some scour rock armour protection, just small size rock to protect those areas. And then as well, there's a bridge in that site crossing over the creek. And I think going forwards, there is plans to do work on the bridge abutment there, so that'll improve the scour resistance of the bridge abutment.
Thank you.
It was something we did, yeah, we did have it in mind when we looked at some sites that were already at risk of erosion.
Thank you. Okay, and finally, how was the Greetham South scheme funded?
So yeah, as I mentioned before, the land was provided by one of the companies affected by the original floods. The second company affected provided some quite a large portion of the funding. There was some funding from the flood and aid grant, and then for some of the smaller items like the construction of the seal hides, similar to Karol was saying, there were little pots of money that we identified and that we used to sort of fund those parts of the work. So I think the RSPB had a fund for kind of improving facilities, and that was part of that was used for the development of the seal hides and things like that.
Thank you very much. Right, so thank you to all of our speakers. That was really interesting presentations, and I hope it's given you all a bit of a flavour of what the study weekends are like and what they're about. And I'm going to hand over to Jo now. She's got a few words she wants to say.
Yes, hi everyone, and thank you very much. I know it's dinner time, so I'll keep this short and sweet, but I'm the Vice Chair of the Rivers and Coastal Group Committee at the moment, and just wanted to really say on behalf of the committee and the group a big thank you to Hannah in particular for her original organisation of the study weekend that wasn't able to happen. So much time and effort was put in by her and a couple of others. So just want to really recognise that effort and thank you for bringing the online event instead, and those who've spoken as well, and also sort of HQ at CIWEM for helping us put it on and make sure the IT was working. I also just wanted to say we're aware that the study weekend's obviously quite an important part of helping people progress towards chartership. There are workshops on sort of CIWEM competencies and yeah, just generally sort of supporting people on their chartership journeys. So what we'd like to do is send out a short survey as a follow-up to this event, just to get any ideas from you as to how we can continue that support moving into next year, so that we can look at being able to do that in a way that we perhaps can't through the study weekend at the moment. So we really appreciate any feedback that you've got on that. That'd be great. And then thirdly, just to really say, we're also planning a series of some webinars over the winter, perhaps one this side of Christmas and then a couple into the new year. They'll just be short, sort of 30-minute to 1 hour events. So keep an eye out. We've got a list of presentations, and we're just putting together a programme and dates and timings for those. So yeah, please stay alert for them. Look out for our LinkedIn group. If you're not already a member, then please join in with that. And otherwise, yes, just thanks to you all for your time and support of the group this evening.
Yeah, thank you very much, everyone. And yeah, I guess we'll let you go get some dinner now. Thank you. Take care.
Thanks, everyone.